All right, class, welcome. Today, we're going to dive into a really core concept for anyone who's going into business analytics, finance, you name it, and that's matrix operations. We're going to start with the basics, addition and subtraction. Now, I know, it might sound like simple math, but trust me, getting this right is the absolute first step to building those powerful data models that really drive business today.
So to make this real, let's start with a situation you'll definitely encounter. Imagine you're a regional manager, and you've got two stores. Let's call them location A and location B. Every month, you get a sales report from each one. Your boss wants one single report that shows the total performance for the whole region. So how do you do that? How do you combine them efficiently and, more importantly, accurately? This is a fundamental task, and as you're about to see, matrices are the perfect tool for the job.
So how do we handle all this data? Well, we use something called a matrix, and don't let the fancy name intimidate you. At its core, a matrix is just a grid of numbers organized in rows and columns. Think of it like a spreadsheet without all the buttons. In our sales example, the rows could be your different products, laptops, monitors, keyboards, and the columns could be the sales for quarter one and quarter two. And the reason this is so powerful is that computers, whether it's Excel or specialized software, are built to process these organized grids of data incredibly fast.
Now, here's where it gets interesting. You can't just take two spreadsheets and mash the numbers together any way you want. It's not the Wild West. In mathematics, just like in business, there are rules, procedures that guarantee your results are accurate and meaningful. And when it comes to adding matrices, there is one single, non-negotiable rule you have to follow before you even think about doing any math. I like to call it the golden rule.
And here it is. The golden rule is beautifully simple, but absolutely critical. To add or subtract two matrices, they must have the exact same dimensions. That means the same number of rows and the same number of columns. This right here is the single most important concept we'll cover today, because this is where almost all the common mistakes happen. And a mistake here isn't just a simple calculation error. It makes the entire operation logically meaningless. Your results are totally invalid.
And this slide shows you exactly why. Take a look. On the left, we've got a 2x2 matrix, 2 rows, 2 columns. On the right, a 2x3. Now let's put that in a business context. Imagine the first matrix shows sales for two products in Q1 and Q2. The second one shows sales for the same two products, but for Q1, Q2, and Q3. See the problem? If you try to add these, what do you do with that third column of data for Q3? There's nothing to add it to in the first matrix. It's like comparing apples and, well, apples and oranges. It just doesn't work.
Okay, so now that we have the golden rule burned into our brains, let's talk about how we actually do the addition. And here's the good news. Once you've checked that the dimensions match, the process itself is incredibly easy. It's really intuitive. All the hard work, the critical thinking, is in that initial setup and verification. After that, it's just simple arithmetic.
You can think of it as a simple three-step recipe. Step 1, and I'm going to sound like a broken record here, but it's that important, confirm the dimensions are identical, always. Step 2 is to find the numbers that are in the same spot in each matrix. We call those corresponding elements. And finally, step 3, you just add those corresponding elements together. That's it.
So I just use that term corresponding elements. What does it mean? It's really simple. It just means the numbers that are in the exact same address, the same position in each matrix. The number in the top left corner of the first matrix corresponds to the number in the top left corner of the second one. Think about a spreadsheet. You'd add the value in cell A1 from your first sheet to the value in cell A1 in your second sheet, right? You wouldn't add A1 to C5. It's the exact same logic here. The position is everything because it's what gives the number its meaning.
All right, enough theory. Let's get our hands dirty with a real example. We're going to walk through this step by step so you can see the golden rule and the element by element mechanic in action. This is precisely what you would do to combine those two store sales reports we talked about at the beginning.
Okay, here we are. We have matrix A and matrix B. Now, what is the very first thing we do every single time? That's right, we check the dimensions. So let's look at matrix A. It has 2 rows and 2 columns, so it's a 2x2. Now look at matrix B. Also 2 rows, 2 columns. Another 2x2. Perfect. The dimensions match, the golden rule is satisfied, we have the green light to go ahead and add them.
So we'll build our new answer matrix piece by piece. Let's start in that top left position, row 1, column 1. In matrix A, we have the number 1. Its corresponding element in matrix B is 5. So we just do 1 plus 5, which equals 6. And that 6 becomes the very first element in our new matrix.
Easy enough, right? Let's keep going. We'll move across that first row to the second position, which is row 1, column 2. In matrix A, we've got a 2. In matrix B, we've got a 6. Add them together, 2 plus 6 is 8. And there's the second element of our answer.
Now we just move down to the second row. We'll start in the first column again. So, row 2, column 1. You see the pattern. We grab the 3 from matrix A and its partner, the 7, from matrix B. 3 plus 7 gives us 10. And for the final piece of the puzzle, we look at that last spot, the bottom right corner, row 2, column 2. We take the 4 from A, add it to the 8 from B, and our final element is 12. And just like that, we're done with the calculation.
And voila! Here's our final result, which we can call matrix C. Now, notice something really important here. What are the dimensions of our answer, matrix C? It's a 2 by 2, right? It's the exact same size as the 2 matrices we started with. And that's not a coincidence. This is a key property of matrix addition. The result always has the same dimensions as the originals. That preserves the structure and the meaning of our data.
Okay, so we've pushed some numbers around. Fantastic. But this is a business administration course, so the most important question you should always be asking is, so what? Right? Who cares? Why does this simple little calculation actually matter? How does this help a manager make a better decision? Let's connect the dots.
Let's go back to that sales report idea, but think bigger. Imagine Matrix A isn't just one store, but it represents the sales for 4 key products for your entire North American division for a quarter. And Matrix B is the exact same report, but for your European division. When you perform this addition to get Matrix C, what you've just created in about 10 seconds is a consolidated global quarterly sales report. With this one grid of numbers, a vice president can now see at a glance what the company's global bestseller is. They can spot an underperforming product line. This isn't just data anymore. This is business intelligence. This is what drives strategic decisions about marketing, about inventory, about where to allocate resources. This is the real deal.
All right, as we start to wrap this up, I want to boil everything we've talked about down to one single core principle. If you forget everything else from today, though I hope you don't, but if you only remember one thing that will save you from errors in your coursework and more importantly in your career, what is it?
It all comes back to this, the golden rule. Always, always check the dimensions first. It takes 2 seconds, and it is the single best way to make sure your entire calculation is valid. This simple check is your safety net. It protects you from flawed models and from the bad business decisions that come from them. So make it a habit, a reflex. Before you ever add or subtract, you stop and ask, do the dimensions match? No exceptions.
And I'll leave you with a final thought to get you ready for our next session. We've seen today that addition and subtraction, they're pretty intuitive. It's all about combining like with like. But matrix multiplication, well, that is a completely different animal. It's not about combining, it's about transforming data. It uses a totally different set of rules, and it allows us to do incredibly powerful things, like calculating total revenue from separate sales and price data. So think about this before next time. If addition has this simple rule about matching dimensions, what kind of new, maybe even strange rules might we need for an operation as powerful as multiplication?